Hello friends, we are back again with a different fungus, with a new fungus. Uh, this is found in the potato. It is as looking as gray in color, as you can see. If we look at it a bit closer, we will be seeing it is a gray in color, almost grayish black in color, as you can see from this view. It is almost gray in color. If we make a zoom, or if we make a zoom, while zoom is not possible anyway. So we will be seeing this fungus. It is gray in color. So this fungus has a morphology and like Aspergillus fungari, but when I was doing a confirmative research work on this fungus, I found a similar fungus regarding it is there in the database, a similar fungus that is in the botrytis cinerea. But botrytis cinerea is looking same, almost similar in nature. It looks similar in appearance, but it may not be similar in morphology, but or maybe same as morphology, we are not sure. So we will be discussing, or rather deciding that later on, whether this is botrytis cinerea or not. It may be botrytis cinerea, it may not be botrytis cinerea. We will be deciding later on after the microscopic investigation. So first of all, we will be excavating this fungus from the potato, and we will be putting it in the agar, which is little bit different. This is called the Dryglaski selective agar. Again, this agar is different from the MMOM agar, which was previously used in Aspergillus fungari, but this agar is a little bit selective because this protects, or rather inhibits, the gram-positive bacteria. Inhibition of the intervention of this gram-positive bacteria, we are going to inhibit it, and we will be also determining the pH range, or the presence of acidity or alkalinity or neutrality of this fungus in the uh, state, in the fungus matter. So we will be first excavating this fungus, and then we will be putting it into the culture media, and we will be using it. So let us begin the excavation first. So for that, the same thing, we are using a scalpel in the right hand and the tweezer in the left hand, or the forceps in the left hand. We will be just excavating this fungus from this potato, and as you can see, this fungus is quite big enough. Already it has occupied almost center of this potato, and we are excavating the mass. So this is almost hard and crystalline. It has become hard and crystalline. We will be excavating this. Excavation is difficult because this is very hard fungus. So it is coming out. Just cut the potato in half so that it will be easier. The excavation will be easier with this scalpel. This potato is cut in half, and so it will be easier to excavate this fungus. Now it is easier to excavate. It is easier to excavate. another part is left. So this is scraped off. Let us scrap it off. So it will be easier to scrap it. Just scrap it off. And as you can see, the excavation is done. So the excavation is done. So this much fungus is available. Little bit more is left. So we can get it from this side with the help of the scalpel. We can excavate. Okay, this scalpel is done. From this, it is excavated. So it is over. The scalpel and the is over. So we will be now putting it in the agar, this type of agar. We have to get a conical flask and we will be putting it into the agar. So we are ready. Now as you can see, the fungal matter is ready, and you can see here the fungal matter is ready. So we will be putting this fungal matter into the flask, and we will be using the dry glass key agar to get this fungus. This fungus is actually little bit different than botrytis scenario, because botrytis scenario is completely sweet based fungus. This is not completely sweet. It is mainly consisting of starch, so sweet and sour actually, but this is not sweet and sour. This is consistingly in a steady medium of starch. So this, for this we are using this diglycol agar, which consists of lactose. So we are using this lactose based agar to see it's already covered, and we will be putting a cork on this, a very similar cotton cork. Yes, cotton cork, it is ready. So we will be putting it, and we will be placing it in the incubator for 5 days. So this culture media is ready. This fungus is ready for incubation. As you can see, it is white in color. This culture media has not changed the color. So it will be seen after 5 days whether it changes the color or not. After 2 or 3 days, we will be able to see whether it changes the color or not. So till now, thank you friends. After that, after 5 days, we will be investigating this culture media. Thank you. Hello friends, after 5 days we are back with this gray mold. As you can see in my flask, it has not changed color, it has just become white, more white. So it is appearing as gray mold. Maybe it may be similar to botrytis scenario. So that will depend. We will see it under microscope today. So what is it? Is it botrytis scenario, or it is something else? But we will be seeing it. So how many things are there? So let us take around 3 ml of, or 5 ml of this extract, and it is become very viscous due to the presence of starch. So let us take it and and we will be seeing under microscope. So let us, this is the extract, as you can see. This is a starch extract. It is almost starch. Because they are having the Phyokyanos, this Phyokyanos Mokhla is having micropores, and this botrytis botrytis cinerea is having very small micropores. So they are looking similar, but they are not at all similar fungus. They are totally different. So you can see from these two comparative videos as in the screen. So they are not at all same. So this is quite interesting, and I can see the comparison images. So both you can see, and it is consisting of micropores, too much micropores. It is a very sporous fungus. It is a sporadic fungus. This is Phyokyanos mokhla is a very sporous fungus, as you can see. So it is not at all botrytis area. It's totally different. So friends, we have just now examined the sample under microscope, and it is very similar to botrytis cinerea, but it is technically not. So we will be discussing about this one. We will be analyzing this fungus regarding in future, but it is technically similar to botrytis cinerea, but it is absolutely not. It looks like botrytis cinerea, but it is having profuse myco spores. Actually, the microspores has developed, so it is mainly sporadic mold, we can say, or rather I have named it as Phyokyanos Mokhla. Actually, I have named it as Phyokyanos Mokhla. It is only it's a blue-grayish mold. So it is very similar to botrytis, yes, indeed, but it is not botrytis cinerea, as you have seen under microscope. So we will be discussing about later on. After 2 or 3 days, we will be analyzing the mycotoxin and the fluorescence display or fluorescence vision of this specimen. We will be seeing under fluorescence microscope. The microscope just next to me is the fluorescence microscope. So we will be discussing with that, and we will be analyzing under that, and we will be see whether it is having any different type of mycotoxins, or is it same as my botrytis cinerea or not. That we will be seeing after that. By analyzing the mycotoxin, we will be conclusive. Then it will be a conclusive approach. So let us see what happens. Just within 2 or 3 days. So thank you for now. So as you can see, the mycotoxins has been analyzed by the spectrophotometer, and the file is opening, and the file is opening. So the file you can find here, mycotoxin, the spectrum of the UV spectrum of the mycotoxin. The file is there in this folder. So it is opening, and file is opened, and you can see in front of it that it is two mycotoxins peaks are there. One is at 260 nanometer and another is 290 nanometer. The 260 nanometer mycotoxin is trichothecene, and the 290 nanometer at the 290 nanometer the mycotoxin is roquefortine. So it is not botrytis cinerea, it is not botrytal, it is composing of two mycotoxins, very similar to botrytis cinerea, but the mycotoxin. Hello friends, so after this spectrophotometric analysis, it is clear that absolutely clear that is very similar to botrytis scenario. This fungus is very similar to botrytis scenario, but it is not technically it is not botrytis scenario. It is cinerea. It is different kind of mold. It is a mold fungus, very similar to botrytis cinerea, but it is not mold. It is not botrytis cinerea. It is little bit different because the mycotoxins are different. It is having both, but similar mycotoxins, but mycotoxins is different. One mycotoxin is trichothecene, which is very similar to botrytis, and the other mycotoxin is roquefortine. So that is a different mycotoxin. It is not present in botrytis area. So this is technically it is a different fungus. You can say microbiologically it is a different fungus. It is botrytis, not botrytis cinerea. It is though it is having a necrophilic structure, and it is but it does not contain any conidiophores. It does not contain any conidiophores. It is having only micropores spread over that. And as you have seen from the previous in the previous part of this video, that you have seen it is having microspores, dispatched micropores. There is no conidiophores. So necrophilic fungus, it is a necrophilic fungus both, but it is not conidiophores. It does not have any conidiophores. It is not having necrophilic structures, and therefore it is not botrytis cinerea. It is different. Okay, so that's why I have named it as Mokhla. Mycotoxins is a Greek word. Mokhla is also a Greek word. Mycotoxins means a bluish, blackish blue mold. So blue-black mold, or you can say bluish-black mold. So it is like that. It's a new fungus. It's similar to botrytis cinerea. It's similar to stachybotrys atra, because stachybotrys atra is having a trichothecene mycotoxin, and this Phyokyanos Mokhla is also having the same mycotoxin of trichothecene. It's the same micropores. It is having the micropores are very similar to stachybotrys atra. So stachybotrys atra. So that's why it is known as botrytis scenario. Botrytis. It is having a botrytis. So it is similar. These three funguses are very similar. Botrytis scenario, stachybotrys atra, Phyokyanos Mokhla, these are all similar molds. These are all starch dependent molds. These are all sweet dependent molds. These are all dampy, cold dampy region molds. They are generally developed in refrigerators, prolonged keeping of vegetables in refrigerators, and also in cold storages. As you will see, this is the bad effect of keeping vegetables for a long time in cold storages. These molds are formed inside the vegetables, which is not found in outside the surface of the vegetable. This is actually found. It has been excavated, as you have seen in the very previous part of the video, the first part of the video, the extraction part, that it is has been excavated from the middle part of the potato. The whole part was fine and beautiful, and the middle part was full of water. It is Phyokyanos Mokhla. It was excavated by me, and you've seen the mycotoxin. It's a very dangerous mycotoxin. It's a very dangerous fungus, and the fungus consisting of the mycotoxins is also very dangerous mycotoxins. The trichothecene and roquefortine, both are containing mycopores. There's a amount of mycoporous mycotoxins, so both are bad for the respiratory system as well as for digestive system. And they are very, what should I say, it's very porous and very airborne microparticles. These are all airborne mycopores, and these airborne mycopores, like trichothecene, is an airborne mycopore, and it's very dangerous. So I can conclude here throughout this video that this is not botrytis scenario. It is a little bit different fungus. It's called Phyokyanos Mokhla, as we explained. So you can take it as a fungus, and therefore it should be taken care of the vegetables when keeping in fridges and refrigerators and cold storage and purchasing from cold vegetables and all that. Phyokyanos Mokhla should be very carefully treated. Vegetables should be carefully treated, watched before cutting and cooking. So, thank you for now.